Oh, lung cancer? You should take a CT scan of your lung. Let's go!
Upon the discovery of a space-occupying lesion on a plain chest X-ray, a plain CT was arranged to assess the size and the location of the mass. An elliptical field is first selected to exclude preventable artifacts such as the CT couch, then we crop to only see the pixels within the region of our interest. A histogram describes the distribution of pixel values in the image. The cluster of peaks at the left end represents the surrounding air in lung, and some tissues within the lung and fat with low densities, while the peaks on the right represent denser tissues such as muscle, blood vessels, and bones with higher pixel values. In the attempt to delineate the mass from other structures, thresholding is applied to the image. Thresholding consists of segmenting an image into two regions. This process works by setting all pixels that belong within the selected threshold interval to white and setting all other pixels in the image to black. To separate the mass from the lung, the simplest way is to separate it from the air inside the lung with very different intensities. We include all the air and low-intensity pixels in the threshold interval to leave the higher-intensity pixels, which include the mass, to outside the interval. The resulting image is referred to as a binary image. The image can then be inverted for easy viewing depending on the preference of the viewer. A Gaussian blur filter is applied to smooth the edges and reduce noise so it is easier to identify a continuous edge. According to preview, small radius is chosen to avoid too much blurring of the borders. Finally, using the function find edges under the tab process, the approximate edges and the contour of the mass is identified. This method is not ideal to segment a tumor mass from surrounding tissues of similar densities. This is apparent when a line intensity profile is plotted by the software. We can see that the gray value of the mass has almost the same gray value as soft tissues, which makes it especially difficult to separate it from the posterior wall tissues where the mass seems to have adhered to. The doctor suspects malignancy based on the location and the size of the mass and orders a PET-CT scan to be performed. PET, or positron emission tomography, utilizes radiopharmaceuticals that emit positrons to target specific regions of the body based on uptake levels. When F18-fluorodeoxyglucose is used, the modified molecule will be trapped within the cell because it is incompatible with the enzyme in the next step of the glycolysis pathway. Tumors overexpress facilitated glucose transporters and the glycolytic enzyme, hexokinase 2, and so the uptake level will be significantly higher in tumor cells than normal cells. The intensity of the red color will be higher in the region of the tumor. In order to visualize the location and uptake level of the tumor suggestive of its malignancy, an overlay is performed between the functional PET image and the CT image. Under the tab Image and Color, select the Merge Channel function. PET image is assigned as the red channel, while the CT image is assigned the grayscale channel. A composite image will be created afterwards. Overlaying the two PET and CT images will give us useful information on the anatomical structures relative to uptake of traces, which will indicate the level of activity within the tumor.
Oh, it's your CT lung. Oh, not here. You should take a PET-CT. Let's go again.
.3D Slicer is an application that can combine sets of two-dimensional image data to produce a three-dimensional volume and display it on a screen as 2D images. After importing the 2D CT slices from the patient's CT examination, we can go to the Editor toolbox, then edit selected label map and choose the Paint tool here. Since our region of interest is the lung field, we simply need to use the painter to highlight some lung field by excluding the tumor. By using the fast marching effect, the computer will automatically calculate the entire region with similar densities as what was selected. The software will select the entire region of interest in all the slices, so fine adjustments to the expected structure volume or maximum total volume are necessary to exclude the unnecessary area. By choosing the make model effect after selecting the ideal region of interest, the 3D lung volume can be rendered to give a model of the patient's lung, based on CT data. In order to have a better visualization of the relative position and size of the tumor within the lung region, the tumor volume can also be rendered under a new structure label. Using the same procedure of paint effect and fast march with fine adjustments to the expected structure and maximum total volumes, a three-dimensional model of the tumor can be obtained. Now the relative position of the tumor within the lung is demonstrated in 3 dimensions for accurate visualization and surgical planning. Information about the volume of the tumor can be found under the Model tab, whereby the software calculates the estimated volume to be 15,400 millimeters cubed.
Stop talking, you are late. According to your PET-CT image, you got a lung cancer. Oh, lung cancer? I'm afraid your family member may also have the chance of getting lung cancer, so you guys better do a genetic test. Oh, lung cancer. Let's go again and again.
Since the patient lives together with his relatives, there is a chance of the relatives to have lung cancer due to prolonged exposure to secondhand smoke carcinogens. A genetic test was run, and in particular, chromosome 7 containing the epidermal growth factor receptor, in short EGFR, was picked out. BLAST, or Basic Local Alignment Search Tool, is an algorithm which performs sequence alignments and calculates alignment scores to indicate percentage of homology. Under protein BLAST, the amino acid sequence of the relative's chromosome 7 is placed into the box. Reference proteins database is chosen. BLAST will run the query protein sequence against its normal variants in the database. BLAST breaks down the query sequence into words and matches them with possible target sequences. Alignment score for each match will be calculated by the algorithm. The extension of words will be done from the start to the end, and alignment score for each match is computed repeatedly until a set threshold is reached or the entire sequence has been scanned. Here shows the results of matches between the query sequence from the patient's relative and amino acid sequence in the database. There are many sequences with very high percentage of similarity to the query sequence. We are only interested in the Homo sapiens sequence with 99% similarity. The expectation value of 0 means that there is 0% chance that the alignment was due to chance, therefore they must be homologous. The exact comparison between each amino acid will be shown, with mismatched pairs represented as gaps. According to this result, there is a substitution mutation at amino acid position 858, where leucine in subject sequence was replaced by arginine in query sequence from the relative. Further information about the EGFR gene can be found in the links at the site, with relevant details of the domains of the gene and literatures shown. Upon discovery of this substitution, the doctor realizes that this mutation has a 43% frequency of occurring in the EGFR mutated lung tumors, which means that this relative might have a chance of having lung cancer. Let us send our best regards to this unfortunate family.